Hello, ladies, gentlemen, and in between, and welcome to another episode of Maths with Hamblin with your beautiful host, Hamblin. And today, my boys, we're going to continue our study into quadratics, and we're going to find out the second method for solving quadratics, which is called completing the square. So let's get into it, my boys. Okay, so my dear viewer, to start, I want to direct your attention to this quadratic polynomial up here, and I'm going to ask you to try and solve f of x equals 0 here. Now, the only method we've learnt so far, which is factorization, if we try and do that method here, well, we could think what two numbers can multiply to minus 10 and add to 8, and if you really rack your brain to think about it, you come up with nothing. There are no integers, at least, that will add to positive 8 and multiply to negative 10, so this is a case of a quadratic where factorization will not work. We cannot possibly break it up into two linear factors, at least with integers to our knowledge. So we're going to need a new method to solve quadratics, and completing the square is this new shiny method, and it will work for every single quadratic, because factorization doesn't work for most quadratics because it's rare you'll manage to get a lucky combination of two numbers where you can add them to get this and multiply them to get that. So to start with completing the square, I'll just write down the actual equation we're asking. So we want to solve f of x equals 0, so let's just write that down. Rightio, and what I want to just have a leap of logic with you right now, viewer. So I want you to consider this. Consider x plus 4 squared. And you'll notice 8 is half of 4, and that is for a very particular reason. So let's expand this and see what we get. Just go with me on this, right? So we're going to get x squared plus 2 times this times that, which is 8x. Alright, notice some similarities there. And then plus this thing squared, which is 16. Okay, now you might ask me, how does this help us? Well, look at this. This is in common with this. So all we need, if this 16 was on the other side, which would just be brilliant, then we could have just collapsed this thing into just a single bracket squared. And you'll notice that will make it very much easier to deal with, because then we'll just have an x to the first power here instead of an x to the second power, and we can just square root to get rid of it. But there's a problem, right? There's this 16's here, but it's not here, so this can't help us, right? No problem, my dear viewer, because if we could add 16 to both sides, then suddenly this left-hand side will be in the correct form, and then we can collapse it down into a bracket squared, and it will help us immensely. So let's add 16 to both sides, and while I'm at it, I'll also move this 10 over. So if I add 16 to both sides, well, I'm going to get x squared plus 8x plus 16, which is exactly what we want, and that equals, well, I've added 16 to this side, and I'm just going to add this 10 over as well, so we're going to get 26. Do you know what's great about this, viewer? Do you know what's just fantastic? This is exactly equal to that. So we can equivalently write this whole thing here is equal to x plus 4, all that squared equals 26. And now look what we've done. This is really special. This is very important. We've turned this nasty quadratic and we've collapsed it down into a single bracket squared, which will help us immensely, because look what happens now. If we take the square root on both sides, well, the square root of a thing squared, that'll cancel out for obvious reasons. On this side, we're just going to get the square root of 26, right? Be careful, because if you recall, if you square root a number, you can get a positive and negative answer. And if you don't believe me, consider like a squared equals 4. Well, you could just take the square root and get a equals 4. A equals 2, sorry. But you can also get a equals negative 2. Because if you square negative 2, you'll get minus 2 times minus 2. The minuses will cancel and you'll still get 4. So when you take the square root, you must be careful. If you want to be thorough in getting all the solutions you can, which is exactly what we want here, if we want to get all the roots of our polynomial, then we've got to make sure to take the positive and the negative version of our square root. So this, I'm going to write plus minus root 26, which reminds us that we can either take the positive or the negative root of 26 in finding our solutions. And now I can just move this minus 4 to the other side. And boom. Look at that. We've done it. We've taken this unfactorizable quadratic, which is terrible, and using this seemingly magic method here, we've found a solution like that. And by the way, important thing to note, when you have a solution written down in terms of surds like this, That's called the exact solution. And the reason it's called that is, well, if you try to, well, remembering that 26, that will be irrational, or the square root of 26 will be irrational. And if you try to approximate these numbers here, this value of x, as a decimal expansion, you're never going to get exactly right because the decimal's gone forever. You always get an approximation. But if you include the surd and not just a decimal approximation, you'll get the perfect exact answer. So when a question asks you to leave your answers in exact form, this is what it wants in surd form. And boom, let's just take a second to recall what we did, because it was very, very important. So we looked at our quadratic and we thought, well, how can I collapse this down into a single bracket? And we found that if you take half of this coefficient and then chuck it in this bracket squared, you get exactly what you need plus this nasty constant. So all you need to do is add this nasty constant here, which is half of this number squared, onto both sides, and then you can suddenly collapse this down into a bracket squared, and then you can just solve for x nicely. Right, so let's go over another example, my boys. Okay, so my lovely people, we're going to now use that lovely method which is called completing the square, by the way, because you're adding a number on to complete the squared bracket. It's a nice little name for it. So we're going to use that method we learned here, and first we're going to note that if we halve this number here, making sure to keep the negative, so that when we expand it we get the correct thing, then that'll be, or x squared times this times that times 2, which is minus 6x, and then we've got plus 9 here. And so, if we want to find the roots of this function, all we got to do is add this nasty little leading 9 onto both sides, and then we can solve. So, if we set this up, okay, so we want to find the roots of this function, so x squared minus 6x minus 20 equals 0. Now, all we got to do, if we add this 9 to both sides, suddenly we'll have this side equal to this, and then we can solve it very nicely. So let's do that, and also move this 20 over. So x squared minus 6x plus 9 on this side, and then I've added this 20 over, and I've still got to add 9 on this side to maintain the equality. And then boom, that's a lovely, beautiful little thing that we can collapse into a squared. That is equal to x minus 3, all of that squared equals 29. Take the square root, remembering that when you take the square root, you can get a positive or a negative answer, and then you just add 3. And boom, my lovely boys. That was pretty easy, right? Almost as easy as factorization, just a little more legwork. So when factorization doesn't work immediately, when it's too much brain work to think of two integers, where you can solve your polynomial like this and turn it into two linear factors, you can just use this lovely method called completing the square to go through it like that and get a nice solution for x. Now, I'd like you guys to remember what we did here, because that is very, very important. I know be very important for learning what we do in the next episode, which will be deriving the quadratic formula. So I'm just going to go through one more example, this time a little bit harder, could be quite similar to factorization actually, and then I'll leave you for this video, guys. I'm so sorry. Okay, so my boys, before I leave you off, I'm just going to leave you with this little bit of a harder example, and much like with factorization, when you have a number that's not 1 in front of the x squared, it muddies things up a bit, and I'll show you why. And you can probably see why already, but if we try and apply our method, so we take 2x minus 3, because this is a 2x squared, so I've carried the 2x there, and we square that, we're not going to get something that matches this nicely. We're going to get 4x squared in the front, because when you square this, you'll get a 4x squared, dot, 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 dot. And so, if you try and you can't just add a single number to suddenly make this equal to this, because you'll have to add another 2x squared, which will introduce another x squared term, which will completely defeat the point, because then it will just make it just as hard to solve, in fact a little bit harder. So what a clever thing we can do here, my dear viewer, is divide everything by 2. So if I just set up the equation here, right, lovely, lovely, what we can do here is, well, if we divide everything by 2, that's okay, right? Because if we divide everything by 2, then on this side we'll still get 0 divided by 2, no problem. And we'll have an x squared here, so we can use our method. So let's do that. If I divide everything by 2, I'll get this. Remembering that 0 divided by 2 is 0, so that's fine. And then we can just apply our method and half this number. Right, that's not going to be too nice, but you've got to do what you've got to do. And if we expand this, we'll get x squared plus, okay, right, let's think about this. 2 times this times that, that's just going to be minus 3x. Okay, exactly what we hoped for. And then we're going to get this plus, well, 3 over 2 squared, which is 9 over 4. So we're going to have to add 9 over 4 to both sides. So if we just do that from the original equation, moving this 10 over as well, we're going to get 10 plus 9 over 4. I could simplify that, but right now I just can't really be asked. Okay. Oh yeah, and then there's this plus 9 over 4 on this side, sorry. And then we can collapse this thing down into x minus 3 over 2 all squared equals 10 plus 9 over 4. And then we can take the square root and add on both sides, and we finally get that x equals 3 over 2 plus minus square root of 10 plus 9 over 4. So there we go, my boys. We've completed the square with a bit of a harder one. And that was a little bit more effort, but you'll notice that completing the square will always work, because it doesn't really matter what your coefficients are. You can always go through this process, unlike with factorization. And so that, my boys, is completing the square. To sum up, you look at your quadratic, you halve this number if it's just an x squared, not like a 2x squared, and you chuck it in squared brackets, and then you add on to both sides of the equation. You add on this number squared, and then you can do this lovely process here. So I want you to really understand this. I'm not going to do a follow-up practice questions video, because really this is just a setup for the next video. So make sure you understand this process. So you don't really have to do many practice problems, just make sure you understand it. And that's all I got for you today, my boys. Thank you very much for watching this lovely episode of Maths with Hamblin. If you liked it, smash that subscribe button, smash that like button, and I'll see you next time.